Hello, students. Let us again start our discussion with the remaining topic from the androgen. In today's discussion, we are going to observe the some of the biological activities of the androgen. As in the last lecture, we have studied the basics of the testosterone along with its structure. Then, along with that, we have seen the structure activity relationship study of the androgen. An example was the testosterone, isn't it? We have seen its SAR in more details. Now, in today's lecture, we are going to cover up the remaining part from the androgen, the examples given in the androgen, its biological activity. Metabolism and SAR, it is already over. After finishing the biological activity of the androgen, then we are going to start with the progesterone. In your syllabus, only the single word have been given, that is only the progesterones, isn't it? So though they have not been given any single example, we are going to observe the structures of different progesterone, what activity they reflect. Okay, and most of the progesterones, they are also going to get cover into the oral contraceptives. For example, the mifepristone, which is the antagonist of progesterone receptor, then norgestrel, levonorgestrel. These are some of the examples of the derivatives of the progesterone. Okay, so now let us start our discussion from where we left behind. So I have once again displayed over here the biosynthetic route of the different steroidal hormones in a human body, which has started from the cholesterol, then it is going to get converted into the pregnenolone, that pregnenolone is going to get converted to the progesterone, and so on. We have seen the biosynthesis of corticosteroid, then estrogen, testosterone, isn't it, as well as some of the androgens, isn't it? Okay, so now let us move forward with the today's topic. So now we have seen the example of androgen, that is the testosterone, which is only active when it is going to get converted to 5-dihydrotestosterone, isn't it? We have seen its classification also, and we know that in the case of androgen, we are having only two examples, testosterone and nandrolone deconate, isn't it? So we have seen the SAR of this thing. We also seen the metabolism. So testosterone, it is undergoing the metabolism using the two enzymes, 5-alpha reductase and 17-beta hydroxysteroidal dehydrogenase, isn't it? To give you the androstenone, EP, androstenone, and another derivatives. Okay. So now in the today's class, we are going to observe the different biological activities displayed by the androgen. Okay, so now testosterone and its dihydro derivative causes the pronounced musculizing effect. Okay, even in the male fetus, it induces the development of the prostate, penis, and related sexual tissues. See, what is the very pronouncing pharmacological effect of testosterone, isn't it? So the development of male characteristics, not only in a normal male individual but also in the fetus, it is going to have pronounced musculizing effect that is going to shape the, what you can say, the human character, male character in the fetus also. So at the puberty, the secretion of testosterone by the testis increases in a great manner, leading to an increase in a facial and body hair, deepening of the voice, increased protein anabolic activity, and muscle mass, as well as there is a rapid growth of long bones is there. There is loss of some subcutaneous fats also there. spermatogenesis begins and the prostate and seminal vesicles increases in activity, isn't it? So all these biochemical processes, they are related with displaying the male character, isn't it? So testosterone is also responsible to increase in the size of the sexual organs. The skin becomes thicker and sebaceous, isn't it? So sebaceous glands increases in number, leading to the acne in many young people, isn't it? So generally the young individual, young male, they are having the problem of these pimples due to the higher percentage of the testosterone. The androgen also plays important role in male psychology as well as the behavior. Okay, so behavioral changes we can also observe in a developing male. In women, testosterone plays a role in libido, then mood, muscle mass, and strength, as well as in the bone density. So testosterone is not only it is useful for the males, but also it is useful for the females, isn't it? Okay. So for building the muscle mass and to have the strength as well as to increase the bone density, this androgen plays a very crucial role in women also. So now in our syllabus, we are having the two examples. Testosterone, look at the structure that I have displayed onto your screen. Testosterone and nandrolone deconate, isn't it? OR, R means deconate. At that point there is a aliphatic decane side chain is there. Therefore, decanoate, we are pronouncing it like as a decanoate, isn't it? So now, I think mostly the both structures are almost same, but there is slight difference. If you look at the 19th position in nandrolone, the methyl group is replaced or substituted with the hydrogen. Therefore, the N is given at the first of the name of this nandrolone, isn't it? Nandrolone, wherein the methyl group is absent, and in presence of OH at 17th position, the decanoate group have been placed. So, what is the IUPAC of testosterone? It is 17 beta hydroxy androst 4 in 3 on. Okay. So, the IUPAC name of testosterone is 17 beta hydroxy androst 4 in 3 on. Now, the IUPAC name of nandrolone is 17 beta hydroxy ester 4 in 3 on 17 deconate, isn't it? So now these are the IUPAC name of testosterone and nandrolone deconate. Okay. So now let us look at the testosterone. So it is a naturally occurring androgen in a man. In women, it mainly serves as the biosynthetic precursor for estradiol, but also has other hormonal effects. It is rapidly metabolized to relatively inactive 17 ons. Okay, we have seen its metabolic fate of testosterone also. So now next is the nandrolone decanoate. So it has been used in the management of certain anemias. Look at the use of nandrolone for anemia, but the availability of erythropoietin has greatly reduced its use. Okay, so generally we are going to observe the risk to benefit ratio to use this nandrolone decanoate. Okay, so that is all about the remaining part of the androgens and its remaining examples, isn't it? Okay, so let us move on to the next part of our discussion, last part of your topic called as sex hormone, that is the progesterones. Okay, so now when I am going to say the progesterone, so how many carbon it contains? It contains total 21 carbon atom in its structure. Okay, we have seen the basic 4 nucleus, gonane, then androsten, estrane, and pregnane, isn't it? So now the pregnane is the basic skeleton in the progesterone containing 21 carbon atom. So now let us see which are the endogenous progesterones. So the endogenous progestins, the key endogenous steroid hormone that act at progesterone receptor is a progesterone. Okay, PRs means the progesterone receptor. So now, like we have seen in the estrogen is going to show its estrogenic activity by acting on estrogen receptor A and B, or you can say alpha and beta, isn't it? So likewise, progesterone also have two subtype, progesterone A and progesterone B. So now this progesterone A and B is occupied by this progesterone. Now let us look at the biosynthesis. Progesterone is produced in the ovaries, in testes, and in the adrenal glands. Much of the progesterone that is synthesized from pregnenolone is immediately converted to other hormonal intermediates. Okay, so now like testosterone, progesterone is also liable to get metabolized very fast. Okay, let us look at the classification and some of the examples of this progestin. Okay, so some of the derivatives of this progesterone, we are calling them as a progestin. So in progestins, the first class is the progesterone derivatives, isn't it? Progesterone derivatives. So these are some of the examples are methoxyprogesterone acetate, then megestrol acetate, then dihydrogesterone, isn't it? So these are some of the examples of the progesterone derivative. Another progestins are 19 nortestosterone derivative, isn't it? At 19th position, the methyl group is absent, that is called as 19 nor, isn't it? That is the meaning of 19 nor testosterone derivatives. So now it is having the two examples or the two classes. So the first class is the estrane. Example is the norethindrone, or you can say it as the norethistrenone. Then another example is the ethinyl estranol, and next example is the allyl estranol. Then the next class in the 19 nor testosterone is gonanes. So gonanes involves the levonorgestrel, then desogestrel, norgestimate, and gestodin. Okay, so these are some of the derivatives of the gonane. Then some of the are the anti-progestins. So now these anti-progestins, they are basically used for the termination of the pregnancy. Example is the mifepristone. So this mifepristone is responsible to increase the level of the prostaglandins in the early pregnancy. So if anybody want to terminate the pregnancy, so under the registered medical practitioner, these mifepristone tablets are generally prescribed. Another progestins are the selective progesterone receptor modulators. Example is the ulipristal. So this is an example of the selective progesterone receptor modulator. So let us look at various biological activities of the progestins. Okay, so like estrogen, the progesterone has various pharmacological actions, with the main target tissues being the uterus, breast, and the brain. Okay, so at these three body parts, the progesterone is going to show its mechanism of the action. Okay, so that is the uterus, breast, and the brain. So the action of progesterone in the uterus includes development of the secretory endometrium. Then when release of progesterone from the corpus luteum at the end of menstrual cycle declines, the menstruation is going to get begin. So for maintenance of the menstrual cycle, normal menstrual cycle, there is the role of progesterone. Okay, So progesterone is critical for maintaining the pregnancy by suppressing the menstruation and decreasing the uterine contractility. Okay, so the maintenance of pregnancy is a role of the progesterone. So this progesterone plays these important biological activities. Now, if you look at your screen, I have drawn over here the structure of progesterone and I have shown its metabolism. Okay, so now while studying the metabolism, you must have to understand which are the different points where actually the metabolism of progesterone is happening. So now first look at the structure of the progesterone, isn't it? So it contains the pregnant backbone, which contain the 21 carbon atom, isn't it? So we know that how to give the numbering to the such kind of ring system. So the 18th and 19th are the beta methyl group, then 20 is the carbonyl carbon and the 21 is the methyl at the aliphatic chain. So that is the structure of the progesterone. So now this progesterone is undergoing the metabolism at 3 sites. So which are these 3 sites? So the first site is 5 beta reductase. Okay, so fifth position is reduced. Okay, and the orientation of that position becomes beta. Okay, then next position is the third alpha. It is the third alpha, and that third alpha is the third alpha hydroxysteroid, isn't it? Then next one is the 20th position, 20 alpha. So now when these 3 enzymes, they are going to act on to the structure of the progesterone, you are having the 5 beta pregnant 3 alpha 20 S diol, and which is the inactive form of the progesterone. So by looking at these 3 positions, 5 beta, 3 alpha and 20 alpha, we can make the substitutions at these points so that we can have a long acting progesterones, isn't it? So that is the part of your SAR, that is the part of structure activity relationship study. But in metabolism, you just try to concentrate that the 5 beta, 3 alpha and 20 alpha positions, it is responsible for the metabolism of the progesterone. Getting the point? So at this point we are going to end this video lecture. In next time we are going to start with the some of the few SAR points of the progesterone and oral contraceptive agent, which is very small topic, and that is also related to your progesterone, isn't it? So till that time, just revise this content, and in the interaction session we will again discuss all these things in detail. Okay, till that, take care of yourself and your family. Thank you.